Hello coders, welcome to my channel. I am Aniket and today we will discuss question from GFG, that is k times appearing adjacent to ones. Let's read the problem. Given two integers n and k, count the number of binary strings of length n where adjacent one appears k times. Since the answer can be huge, return it modulo 10 raised to the power 9 plus 7. For example, when n is equal to 3 then and k is equal to 2, so there are only one type of string, that is 111 is present, in which there are two adjacent one appear, so that's why there is only one answer in this case. So what are those adjacent ones? First adjacent one is this, so that's why k plus plus, and again this adjacent one, so there are two adjacent ones, so that's why we have exactly k adjacent ones in this string. So this string is only one type of string, so that's why this answer is 1. What happens if n is equal to 5 and k is equal to 2? When n is equal to 5 and k is equal to 2, so the answer is 6. Why? Because there are 6 types of strings possible, binary strings possible. What are those? If you carefully see here, here also k is 2 because the consecutive ones, the adjacent ones appears two times, first here and first here, so that's why k is equal to 2, so there are exactly two adjacent ones. And here also there are only two adjacent ones, and this one is not counted as adjacent because there is no attachment of this one to other one, so that's why this one is not counted. Only these two adjacent ones is counted. Here also there are two adjacent ones, and in this string also there are two adjacent ones. So I hope you understand the question and what is the asking the question. So let's jump to the solution. So which approach we should prefer? So in question, what we have to do, we want to count binary string. So what is the way? So firstly we have two choices. We have two choices to build a binary string. What are those choices? First choice is either first choice is place a 1, and second choice is place a 0. In this way you can easily construct a binary string. So let's say there are n positions, n is equal to 4, and here you have two choices, place 1 or 0, place 1 or 0, place 1 or 0, place 1 or 0. So total of 2 raised to the power 4 binary strings can be generated through this method. So number of binary strings can be very large. That's why in this question it is giving you that you have to return your answer as 10 is to the power 9 plus 7 modulo. So that's why you have to do this, so that your answer will be in the integer range. Now question arises that which approach you should use in this case. So question is which approach we should use. So in this question we have choices, either we place a 1 or place a 0. So that's why this is a strong hint that we should use DP. So DP is used when there are choices or selection. So we can use DP. Now question arises that what are the parameters used in DP? So what are the parameters we should use in recurrence? And later I will do memoization. So this problem will become DP problem. So what are the parameters we should use in recurrence? The first parameter we should use is id, that is the index of the placement. So we have to consider which index we have to place. So for this index id is 0, for this id is 1, so that's why id is very important term we should consider to build our binary string. Now next important term we should use is prev, because in this question we have adjacency type of thing. Whenever an adjacent type of thing is given to you, so that in that case you have to store prev, that is previous number, previous number. So there are two types of previous number, either it is 0 or either it is 1. So let's say a string is given to you 0 and 1 and 1 and 1. So in this case, if you put 1 here, so in that case the previous is 0. If you put 1 here, in that case the previous is 1. So I hope you understand what is the significance of this previous. So previous store the previous value, that is either 0 or 1, before id, or you can say the value present at id minus 1. So you can say that value of id minus 1. I hope you understand it. Now the next parameter we should consider is k, which is the remaining allowed adjacent ones. So there are only three types of parameter we should use in our recurrence. Now let's discuss the state transition of this recurrence. So what are the state transition? So for this we will consider the length, we will consider two length of string, that is 0 0, 0 1, 1 0 and 1 1. So for this placement, if you want to place 0, so what is the recurrence, and if you place 1, so what is the recurrence? So first let's discuss the simple case, that is place a 0. So if you place a 0 and the previous is 1, then what is the recurrence? So let's say for this prev the id is 0. So what is the next recurrence? So the next recurrence, the next state transition is go to id plus 1 and with prev. Now prev will become 0 because you place 0 here. So that's why for next recurrence the previous is 0 itself. Now what is the k? Does it uh, does it changes the value of k? No, because after placement of 0, it doesn't give, it doesn't decrease the value of k. So that's why the k values remain same. So this is our next recurrence. So for id comma id plus for id comma 0 comma k, you just go to id plus 1 comma 0 comma k. So if you place a 0 in that case, so when you place a 0 when your previous is equal to 0 again, so in that case what is the transition? So for the id your previous is 0 and you have remaining k adjacent ones allowed. So the next transition will be id plus 1 comma, because you place 0 again, so that's why your previous is 0 for the next recurrence. And what is the value of k? Does it affecting the value of k? Placement of this 0 affecting the value of k? No. So that's why the k values remain as it is. Now let's discuss the placement of one case. So if you place 1, so what are the various state transitions? It is an interesting case. So when prev is equal to 1, and what is the state transition? So let's say you are currently at pre id comma prev is equal to 1, and your k is this, and the first case I will consider as place 1. So if you place 1 here, so the next transition is simply id plus 1 go to the next index, and your previous is again 1 itself, because for this you place 1, so that's why for next recurrence this 1 will be the previous value. I hope you got this. And for this case now k will decrease by 1. Why? Because you place two adjacent ones. This is the case of this. So you place two adjacent ones, so that's why your k will be decreased by 1, because now you have remaining k minus 1 allowed adjacent ones, so that's why this will go to k minus 1. I hope you got this. Now here an important question arises that can we place 1 in all cases? So the answer to this question is no. Why? Because let's say your remaining k is 0. So let's say your remaining allowed adjacent ones is 0. So can you do this type of transition id comma 1 comma k to id plus 1 comma 1 comma k minus 1? No. So this is only allowed when your k is greater than 0. So I hope you got this. Now let's discuss the next case. So what is the next case? Next case is when your prev is 0. So these are the cases. So when your prev is 0, so what is the transition? id comma 1, your previous is 0. So that's why here your previous is 0, and the remaining allowed adjacent ones is k. So what is the transition? You go to id plus 1, and now your previous is again 0 because you place 1. No, here your previous is now become 1 because you place 1 in this case. So for next recurrence this 1 will be your previous value. And does it affecting the value of k, this placement of 0? No. This placement of 1, does it affect the value of k for this placement of 1? No, the answer is no. Why? Because this is the case like this 0 and 1. So the previous is 0 and the current is 1. So when you putting 1, the value of k will not decrease. So that's why the value of k will remain as it is. And we can simply memorize it so that our time complexity will, we can simply memorize these states so that our time complexity is less, and it will not give TLE. So what is the updated time complexity if we use DP with memoization? What is the updated time complexity? So the time complexity is simply these three states. This is three states. So that's why your these three parameters affecting the time complexity of the problem. So for this ID, it can ranges up to n, that is the length of the binary string. And for this prev, there are only two types of prev, that is 0 or 1. So that's why the length of this value can be 0 or 1. So that's why we store 2 only. And for this k, there are k adjacent one we have to store. We have allowed to put k adjacent one. So that's why this k will be given into your DP with memoization DP array. This is a 3D DP. So that's why your time complexity with is approximately O of n into k. So it will not give you TLE, it will simply accept it. So it will accept it easily. Now let's jump to the code. But before that, please hit the like and subscribe button so that it will motivate me to create such kind of intuitive video for you. Now let's jump to the code. Here is my simple Java code for this problem where I do the same state transition as I discussed above. So we have to initialize a DP array of size n, k plus 1 and 2, and this is our 3D DP array. This will represent the ID, this will represent the remaining allowed adjacent one, and this is representing our prev. So in this memo function I do the same ID comma prev, k comma prev, so that there are three parameters in our recurrence. So before discussing the base case, let's jump to the body of this recurrence. So whenever your prev is equal to 1, so this can be the two type of case, 1 comma 0 or 1 comma 1. So if your k is greater than 0, so you can place 1, but then your next transition will be id plus 1 comma k minus 1 comma 1. I hope you got this as I discussed before also. And otherwise we have to consider this transition, that is id plus 1 comma k comma 1. So in that case our k will be not changing because our previous is 0. So there are this type of case. For this memorization, for this recurrence, the case is 1 comma 1, and for this recurrence the case is 0 comma 1. I hope you got this. And for this case, answer is equal to answer plus memo of id plus 1 comma k comma 0. So this is the placement of 0, place a 0. So there are two cases is included in this. So what are those two cases? First case is your previous is 0 and your current is also 0, place a 0. And second case is previous is 1 and the place a 0 again in that case. Because placing a 0 doesn't affect the value of k, so that's why we consider it as a common. So that's why we only need one type of recurrence for this. And finally we will store it into our answer and keep it modulo to mod. So mod value is nothing but 10 raised to the power 7 plus 7, that is given in the problem also. Now let's discuss the base case. So whenever you reach at the last or length of string, so it means you already calculated your binary string, you already form your binary string. So when the remaining adjacent characters is 0, so it means that there are exactly k adjacent ones present in our formed string. So in that case you have to return 1, and otherwise you have to return 0. In counting problem we have to return this type of thing. Return 1 when you found a valid string or valid array, and return 0 when you can't find that string. So I hope you understand my solution code and the intuition behind this code, and how I use memoization to store the various states of this recurrence, so that we will not compute same thing again and again, and it will decrease our time complexity drastically. So I hope you understand my code and the intuition behind it. Please hit the like and subscribe button so that it will motivate me to create such kind of intuitive video. I regularly make such kind of POTD discussions or contest discussions on my channel. So please ensure that you hit the subscribe and like button. So thank you for watching my video.